For about $400 in 1971, or about $2,700 in April 2024, you could have purchased this Sansui 5000A AM/FM stereo receiver. It was rated at 55 watts per channel into 8 ohms at not more than 0.8% THD, and if you drove it into 4 ohm loads, it was rated at 75 watts per channel at not more than 0.8% THD. I'll do the standard tour of the unit. We'll look at the front, the back, and we'll pop the cover off and look in there. Now, this unit did come to me with some problems. Basically, there was no sound coming out, and the tuner had some, it was just kind of stuck. So I did some repairs on it, and I'll discuss the reason why there was no power coming on, and then of course there will be data, and I will tell you what I thought after using the Sansui 5000A. I wanted to give a shout out to my good buddy Ian for the shirt that he got me. I thought it was very appropriate for the kind of stuff that I do. So thank you, Ian. Here's a more intimate view of the Sansui 5000A with it powered on, so you could see the nice backlighting of everything. Starting on the left, we have our power on off switch, 1/4-inch headphone jack, our speaker selector. We can go between 3 sets of speakers, or you can do A plus B, A plus C, or you could turn them all off. Low filter, high filter, bass and treble controls, which are also able to be adjusted for your left and right channels. Volume control, and then we have our balance control here. Tape monitor loop switches here for 2 tape loops, which you could also use 1/4-inch jacks for the B loop. Here is our selector, and we can select our tape head here. Phono, AM, FM, FM auto, or the auxiliary input. This is our tuning knob here, and then we have a mono switch, a reverse switch for the stereo, FM stereo only. We can turn the muting on and off, and we do have a loudness switch here. This obviously is the rear of the 5000A. Starting on the left, we do have some adjustments for the FM stereo tuner portion here. We have a DIN jack for the tape monitor. I'm not sure which one it is, A or B, but there's 2 of them there. And we have a separate input for a tape head input. Back in the day, you might just have a tape head with no preamp, and you wanted to use the receiver for your preamp. Here are our speaker connectors, and you would push them in and then insert your wire. We have our main 5 amp fuse here, and then we have fuses here for the left and right channel, and they're the plus B fuses. We have our AM antenna rod here. We have a switched outlet here and an unswitched outlet there. And then we have our AM and FM antenna connectors there. Here is a view of the 5000A with the cover removed. Our output transistors are here, and you can see our tuner is here, and then we have our tuner section in this area. These 2 guys are the driver boards for the output transistors here. 2 of these big capacitors are for the power supply, and then 2 are the coupling capacitors to the out to the speakers, basically from the output transistors. They are capacitively coupled to the output stage. And there was an issue with the tuning. This little indicator, tuning indicator right here with the LED light on it, wasn't lining up where it should, and this was very stiff. So I oiled the gears in here, or I guess there was probably bearings, and tried to get everything to line up so that the tuner worked fine, and it eventually did. Here's just another closer view of some of the circuitry, a little bit different angle, and our power transformers here. This is an underneath view where you can see these capacitors that are used for both the power supply as well as the coupling from the output transistors. And this is just a different view again of the underneath, showing the circuitry, kind of what's going on there, and just how it was wired. These are the 2 driver boards for the output stages, and it just kind of gives you an idea of what was of what they look like. Now, I mentioned in the beginning of the video that this was brought to me for no sound. Well, it didn't have any sound because the speaker fuses were blown, or at least one of them was blown open, and it has a protect circuit in there, so it was not allowing anything to come out of the one good channel. And the reason was because these two output transistors had shorted and blown open the fuse. Surprisingly, no other resistor or driver transistor was damaged at all, and so it was a fairly straightforward repair to get the two heat sinks out, to get the new output transistors on there, and everything worked fine after that point. Here's our standard THD SNR plot at 1 kilohertz with the 5000A putting out about 5 watts into 8 ohms. The THD looks pretty good, better than 0.089%, and the SNRs are right around 60 dB. Here we have the 5000A putting out a little bit more than 5 watts into 4 ohm loads. And if you compare this with the 8 ohm load case, you can see that our THD is worse with the 4 ohm loads, and the SNR is worse with the 4 ohm loads. Now, we're still looking pretty good as far as the THD. The specification is that it needs to be better than 0.8%, but I believe with the 8 ohm loads it was like 0.08% THD. Here's the frequency response of the 5000A from 20 hertz to 30 kilohertz. And right now it's putting out about 5 watts into 8 ohm loads. The specification is that it should be plus or minus 1.5 dB. And although it does look kind of ugly, if we go to 30 hertz, which would be this point right here, we would be meeting these specifications. At 20 hertz, we're not meeting that plus or minus 1.5 dB. But we are indeed meeting that once we get to about 30 hertz. And at the high end of the band, way over at 30 kilohertz, we've got a little bit of boost. Now, I did adjust the bass and treble controls and the balance control to try to have the channels as close as I could and the flattest frequency response as I could get. Here's the frequency response from 20 hertz to 30 kilohertz with the 5000A putting out about 5 watts into 4 ohm loads. If you compare it with the 8 ohm load case, you can see that the 5000A looks better with the 8 ohm load case at the high end of the band, and at the low end of the band, at least for the right channel, it looks better with the 4 ohm load. So that's kind of the frequency response, and this is after the tone controls have been adjusted to try to give the flattest response. Here we have the 5000A putting out about 55 watts into 8 ohm loads, and the volume was set for a gain of 25 dB. You can see our SNRs are at least 51 dB, and our THDs are better than, we'll say, 0.3%. Now, I wanted to point out that the specification is that it should be less than 0.8% THD at the rated output of 55 watts into 8 ohms. So it is meeting that requirement, although it looks kind of ugly, and you can see you have some noise here from the power supply. This 120 hertz spike is pretty prominent. And in case you were wondering what the harmonics look like with the 5000A putting out 55 watts into 8 ohms, here you have it. We have our even or second harmonics higher than the odd or third harmonics. Here we have the 5000A putting out pretty close to 75 watts into 4 ohm loads. The specification is that the THD should be less than 0.8%, which it is. SNRs are not great. You're around, we'll call it maybe 50 dB SNRs to be nice. And if you're curious what the harmonics look like, here they are. And you can see that the even or second harmonic is a bit higher than the odd or third harmonic, which is not your standard case for solid state amplifiers, but it is this time. Here's the 5000A's output impedance from 20 hertz to 20 kilohertz. The specification says that it should have a damping of 50, and if we calculate the damping factor from this, let's say around 1 kilohertz, we're going to end up with a damping of about 40, which is pretty good compared to the spec. This plot shows the 5000A's crosstalk, and this is with the active channel putting out 5 watts into 8 ohms. The specification is that it should be better than 50 dB, which would be right here, and we're there below about 1 kilohertz, and then above 1 kilohertz we go down to about 25 dB of crosstalk. This plot shows the THD versus frequency at a couple different power levels, and that's into 8 ohms. The specification was that the THD should be better than 0.8%, and we are definitely better than about 0.045% here at the high end, at the very low end of the band, and this is from 20 hertz to 20 kilohertz. The power levels range from about 25 watts to about 1.5 watts here at minus 14.2. Here is the 5000A's multi-tone response. It's putting out anywhere between 4.22 watts to 4.91 watts into 8 ohms. And the volume control is set for about 25 dB of gain, although we're showing 22 to 23 dB of gain. What this equates to is between 10 to maybe 12 bits of distortion-free range. Here is the 5000A's system noise level, as I call it. In this case, the auxiliary input has been selected. Those inputs are terminated into shorts, and we're looking at 8 ohm loads on the outputs. The volume control is set for around 25 dB of gain, and what you're seeing is basically a lot of noise from the power supply, which would be these guys here. This guy right here is the 120 hertz power supply. A hum bar, I'll call it, and it's at minus 56 dBV. Most likely when I hook this up to my speakers, I'm going to hear some hum and maybe some hiss. In case you're wondering what the 5000A's intermodulation distortion looks like, this is what it looks like. We've got a 19 kilohertz and a 20 kilohertz tone injected, and they are adjusted so that we get about 5 watts into 8 ohms. And you can kind of see where we're at. Right here, we're above 20 kilohertz. It's around 38, 40 kilohertz, and here we have just our kind of normal power supply hum here. At 1 kilohertz, we do have the difference between the two tones. This plot shows the effect of switching in the low and high filters as well as the loudness switch. Now our normal line for flatness is this thicker blue line right here, and unfortunately with this particular 5000A, the loudness switch is really doing absolutely nothing. You can see it's kind of just following the line, so there might be something wrong with that part of the circuit. Our high filter right here, this guy right here, does affect the high end of the band, starting here probably at about 1100 hertz. It starts rolling off the high end, and the low filter definitely does have an effect starting at 20 hertz, and it starts normalizing out at about 1 kilohertz. So those two filters seem to be doing something, but the loudness switch does not. Right now we're looking at the phono stage response to a 1 kilohertz 5 millivolt signal applied. You can see that the gain of the phono stage is about 37 dB, and I should point out that it is being measured at the tape monitor 1 record output. You can see also the THD looks really good. However, this SNR right around 39 dB is not very good, and that's because of the 60 hertz hum bar that's going on here from the power supply. The specification is that the hum and noise should be better than 65 dB, and we are not quite there. We're at about 40 dB. So that's because of this. Maybe replacing filter caps in this case would help the situation out quite a bit. Here is the frequency response of the phono stage with a 5 millivolt signal applied. Now this is measured at the tape monitor 1 record output, and it actually looks surprisingly good. It looks better than the normal frequency response of the full amplifier, but it's maybe up 0.8 of a dB, almost 0.9 of a dB at the high end of the band, and both channels are pretty well balanced. So I would say the phono stage frequency response looks pretty good. We're getting a little bit of the 180 hertz power supply noise right here. I should mention that the Sansui 5000A receiver weighs about 30 pounds. It's very solidly built, and Overall, I thought it was fairly easy to use. I mean, it's just a receiver. When I hooked it up to the Wilson Watt 3 Puppy 2 loudspeakers that I use and terminated the 2 auxiliary inputs with shorts and listened for hum, indeed there was 60 hertz hum, 120 hertz hum that I heard. It was a bit louder than normal, but once the music started playing, it sounded fine. You don't really hear the hum then, but it was a little bit louder than most amps. And you saw that in the test data where I said that probably the hum was going to be something that was audible. Now, the main filter caps didn't show any signs of noise on them, so it would have to be caused by some filtering in one of the other power supplies, not the main ones that go to the driver transistors. But for the most part, once it was playing, it sounded fine. I thought the bass was fine once I turned up the bass control. As you saw from the data, it did a pretty good job of meeting its requirements. At the low end of the frequency band, the bass was off, and indeed when I listened to it, I did boost the bass up a bit, and I did have the loudness on. Now, the other thing I discovered once I read the manual, which was after I took the data, the loudness control is only effective at lower volume settings. Some other loudness controls do that, but when I had the volume lower and put on the loudness, you could hear a difference in the bass, definitely. But I had the loudness on and the bass boosted a little bit, and then I thought the sound was fine, bass and treble and all that. It sounded very clean. There's no music playing. You will hear some hum most likely, depending on your speakers and how far away you are from that. But other than that, I thought it did really good. It's a nice looking vintage look to it, and you know, it would be a nice receiver for somebody that wants a basic vintage receiver. I said if somebody wanted to go through it and recap the whole thing, I suppose they could do that and get rid of that low frequency hum that I heard. But other than that, it's a nice unit, and I thought it didn't really get hot or anything when I was playing it loud, and it's, you know, at 55 watts for some reasonable efficient speakers, it's going to do a decent job. Once again, if you have not subscribed to the channel, I hope you will do so. If you liked the video, please hit the thumbs up. If you have comments, I like to hear those from you, and I try to reply back to them. And once again, until next time, have a great day or night.